Hello. So in this class, I'm going to answer maybe some of the questions from exercise 3.3, which your test will be on. And I'm also going to answer some of the questions on, the test yourself questions, question 3, 6, and 9 that I also mentioned yesterday. Okay, so let's maybe start off with an easy question to test yourself. Let's start off with question let's start off with question 6. So this is 3.3, question 6. So it's on page 57, and you're given two Venn diagrams, you're given a Venn diagram containing two circles, and it's 14, 9, and 8. And we call this set over here A, and this set here is the set B. And we're asked to find the size of A. Well, the size of A is everything in this red circle. So the size of A is 23. So part 1, you should have got 23. Part 2, for the same reason, you're going to get 17 because it's everything inside the blue circle. So it's 9 plus 8. And then it's the size of A intersection B. So it's the size of the green area. So it's this area in here. So that's going to equal 9. And then it's the size, I should be pronouncing it as cardinal, I suppose, but let's take with size or cardinal. And it's A union B. And that's going to be equal to everything that is inside the multicolored zone. So that's going to be 14 plus 9 plus 8, which is equal to 23, 31, is it? I think it's 31. Yeah. Okay. So that was question 6. Let's jump now on to question 9. So again, it's 3.3. Question 9. In the given Venn diagram, U is the students in class 2L, H is the students in 2L who study home ec, and G. Have I already done that question? I think I've already done that question for you guys. So let's jump on to the next page there. Let's jump on to page 58. Question 10. So this is on page 58. And copy the Venn diagram shown and fill in the three regions given that. Okay, so this is a bit more challenging. So we're given an empty Venn diagram this time, and we're told that this set here is called A and this set here is B, and we're told that the size of A is equal to 12. So I'm going to put a little 12 beside him. And we're told the size of B is 14. And we're told that in total, in the multicolored zone, there are 22, because A union B is 22. Now, that means that if I was to add A and B and I, the intersection, together, so if I was to add those three zones together, A plus I plus B, the answer would be 22. But if I add up A plus I, the answer is 12. And if I add B plus I, the answer is 14. Okay, I get this thing here because, sorry, you can't see my mouse pointing. I get that A plus I is equal to 12 because this red zone in here, the red zone, yeah, that's A plus I, and that must equal 12. And similarly, the blue zone, B plus I, that must equal 14. Now, we can do this just by thinking about it, or we could maybe use our algebra skills. Our algebra skills are probably a little bit more difficult. That's probably next year's stuff, so I'm going to park that for a second. We might just try and think about this. Right. If I was, let's say, 1, so if there was 1 in between, that would be 1, 11, and 13 in A, in I, and in B. So that's no good, because when we add those together, what do we get? 25. So that's no good to us at all, because we need it to equal 22. So what about if I made I bigger? If I make I bigger, what happens? So if I was 2, we now have 10 plus 2 plus 12, and that is A, I, and B. And that's equal to 24. So for every one that I make I bigger, this total gets reduced by 1. So I need to reduce this total here by 24. I need to reduce that by another 2 to get it down to 22. So I think if I was, so for every one I reduce it by, it makes this figure over here go smaller by 1. I need to jump down 2 more, so I'm going to check 4. If I was 4, A would be 8, I would be 4, and B would be 10. Is that equal to 22? Yes. So that is how I would tackle that problem, okay? Kind of trial and error. There is a much nicer way of doing it that I won't look at this year. We might look at it next year, depending on how we're doing, okay? Right, we then were asked some questions. Question 1. Sorry, so I should fill in my Venn diagram. So my Venn diagram looks like this. A, B, I was 4, A was 8, and B was 10, I think we said, yeah. And the size of that guy is 12, and the size of this guy is 14. Part 1, the size of A intersection B, well, that's equal to 4. Part 2, the size of B without A. So B without A means we take the entire of set B and then we remove this part from it. So it's going to be just the 10. So the size of B without A is just going to be 10. It's just this red zone out here. That's everything that's in B with everything that's in A taken out of that. So that was question 10. Now I'm going to jump ahead to question 14. That should be the hardest question in here. So again, we're on 3.3, question 14, and we're on page 58. I go back to black pen. Copy the Venn diagram and fill in the number of elements in each region. So we have boom, boom, and a square. That's our universal set. That's our A and that's our B. The size of A is 21, so I'll put a 21 up there. The size of B is 16, so we'll put a 16 there. And we're looking at the size of A union B is 30. So that means there's 30 within this green area. So within this green zone, there is 30. And we know there's 43 in total in there. So because there's 30 in the green zone and there's 43 in total, that in my mind tells me that there's 13 going to be out here that are not elements of either A or B. So we now have the same problem as the last time. We know that if there was nothing in here, if the size of that middle, if the size of the intersection was 0, well then we would have 37 elements in the green zone. We'd have 37 elements in the green zone, but we're not allowed to have 37 elements in the green zone. We're only allowed to have 30. So that means that we have 7 too many. So just like the last time, let's see what happens if we put in a 7 in here. Now if there's 7 in there and there's 21 in A, that means there must be 14 out there. And it also means there must be 9 in there. So So let's just check that. 14 plus 7 plus 9 equals 30, the magic number. Okay, so again, I could have tried that with trial and error, or I now know from the last question that the size of the intersection when I have that scenario is the same as kind of the overlap, because I've counted the overlap twice. Okay, so then we're asked some questions just like the last question. It's question 1 was the size of A intersection B, and that's going to equal 7. We don't need the lines. The size of, or the cardinal number of B without A, and that's going to be equal to 9. And then the cardinal number of A union B complement. So A union B complement. So A union B, first of all, is everything I'm going to shade in now. So A union B is everything that I'm shading in at the moment. And then complement, this little asterisk up here, we pronounce it as complement. So the complement of that means everything that's not in that but is in the universal set. So the size of that is 13. Right, now I'm going to then get you guys to answer some questions from 3, 6 or 9. So just to kind of maybe make your life a little bit easier, I might answer question 6 now on page 60. So we have a Venn diagram, and this time we have elements, not cardinal numbers. We have number 3, number 4, number 6, number 8, and number 9, number 2, and number 1, and we call this set here A, this is B, and that's the universal set. And then we have in the Venn diagram on the right, which one of the following statements is true? So 6 is an element of A without B. A without B, oh. So A without B is this zone in here. So that is definitely not true. So number 1 is false. The size of A, or cardinal A, is equal to 2. Oh, that's also false, because it's 3, 4, and 6. So the 6 is also in A. So there's 3 elements in A. So the size of A is not 2. Now the next one is the cardinal number of A union B. The cardinal number of A union B, well, A union B is everything that's in A and B joined together into one set. And there are 3, 4, 6, 8, and 9. So there's 5 elements in A union B, so it's not that. So that's also false. And then IV, which is the size of A union B complement. So that's everything that's not in A union B but is in the universal set, is 2. And that is true because there's only 2 elements out there, the number 2 and the number 1. So we've answered it. Which of the following statements is true? Well, it's statement number 4, IV. So if that question comes up on your test on Wednesday, that will be quite easy, won't it? So keep studying for that test, guys, and I will check in again with you tomorrow. So you know the questions, they were on today's assignment. So it's question 1 to 14 on page 58, and it's question 3, 6, and 9 on page 59 to 61. Okay, so I'll see you guys tomorrow, and we'll do more work for the test, and then we'll have our test on Wednesday. The test, by the way, so I will give you the questions and you will answer them within 40 minutes. So I'll put a deadline of 40 minutes after class starts on Wednesday. So be ready to go for my class on Wednesday, okay? Right, guys, see you tomorrow.